just you have to know the various terms. So current here is IB, current here is IC, this voltage is VCE, this voltage is VB. Okay, now in the exam, possible question is, these values are given. One more information is given regarding the beta. Beta is also given. Suppose if it is 100. And the question is, where is the Q point? Or locate the Q point on the characteristic. So what do you have to do? समझ लो, प्रश्न समझ लो. प्रश्न क्या है? For a given circuit, locate the Q point. So what is Q point? Already the answer is here. So for this circuit, how to determine these two values? How to calculate? See, you have the two loops. This is first loop. You can apply the KVL here. Whenever the loop is there, you can apply KVL. And here is another loop. Output side. So when you apply KVL to the input side, your equation is VCC is equal to IBRB plus VBE. So you can solve for IB. IB is equal to VCC minus VBE divided by straight away just the KVL, nothing more. So it is called fixed bias because once you fix this resistance value, you can fix the operating condition, one operating condition. So once you have IB, can you have IC now? Yes, because your IC is nothing but beta DC times K. Now since the circuit we are analyzing for DC conditions, so there you have to add the Q. Finally, you can add the Q value. So this is just for this applying KVL to the input side. Now if I apply KVL to output side, what is the equation? So start from this point now. VCC is equal to ICRC plus VCE. And if you solve for VCE, that comes to be VCC minus ICRC. And at the end I can add. Right? So this circuit provides two values. One is ICQ, another one is VCEQ. Is it the biasing circuit? Yes or no? Yes. Any circuit which provides these two values, that circuit is called a biasing circuit. Is it the complete definition? A circuit which provides the values ICQ and VCQ is called a biasing circuit. It is some partial definition. It is the partial requirement. So what about the position of the Q point? The Q point should be at the middle. So once you fix that Q point at the middle, it should remain there irrespective of operating conditions. So another condition is biasing circuitry not only gives the two values, not only determines the Q point, but another requirement is whatever that Q point is there, that should be stable. That should not vary with change in operating condition. That is said to be a biasing circuit. Okay, so for this circuitry, if I now calculate S, इसका आंसर कब मिलेगा मुझे? Whether this circuit is providing stability or not? When I am getting the answer? After analyzing this one, after getting the equation for S. So how to calculate S now for that circuit? S फक्त करायचे ना? DIB by DIC. So if you differentiate this equation, first you have to solve this for IB. इसका कैसा आएगा IB? IB is equal to VCC minus VBE divided by RB. So for the given value, already you have designed this one. Design के बाद क्या कर रहे हो तुम? You are checking for S. This value is constant. these values are also constant, right? So IB value is fixed, and you are differentiating IB. You are differentiating a constant with respect to IC. So what is the dIB by dIC? Yes, it's 0. Derivative of constant is 0. So if you place this dIB by dIC here, so what you have, S value is there. This S value comes to be 1 plus beta. And beta is having higher value in the range of 100 to 100 like that. It means that whatever the stability factor is there, that is on higher side. And if it is on a higher side, whatever the stability is there, that is on lower side. So this fixed bias circuit provides less stability. That's why practically this circuit is not used. Okay? So this is one interpretation. You can make use of those equations. Another interpretation is if there is change in temperature. Pay attention. So whether your attention is here? Everybody? If there is change in temperature, what is the process? ICO changes. IC changes. And again temperature changes. Now you have to think, is there any provision made in the circuit for compensation in IC, change in IC? If temperature, with the increase in temperature, if IC increases, is there any provision in the circuit? Is there any feedback? We'll come to that part. Is there any feedback? Feedback stands for, is there any connection from output to input? Already you have given the feedback, is it not? Right? So feedback is a process of giving some part of output back to the input. Whatever the things you received from the staff member, you have given part of it back to me or back to the person who is taking the feedback. Similarly, here, is there any connection from output to input? No. That means whatever feedback concept is there, that is not available in this circuit. Because of that, there is no provision for compensation. So suppose you have another circuitry, we will come to that one. And if that circuitry provides compensation, compensation का मतलब क्या है? If there is increase in temperature, collector current increases, and there is provision for decreasing the IC. In the circuit design itself, if there is provision, इसका मतलब क्या हुआ? Yes, that circuit is better than this circuit. So that's why you have to go for another circuit, and that circuit is nothing but collector to base bias. Okay. So what is the limitation of this circuit now? Advantage to both है. The circuit is very simple. Just you have to take a device and the two resistance. That's all. Design is also simple. So design में क्या करना है? Suppose I want to design a fixed bias for 5 volt 5 milliampere Q point. Pay attention, don't write. क्या करना है मुझे? Fixed bias I have to design for 5 volt 5 milliampere. तो 5 volt का मतलब this value is given. 5 milliampere का मतलब this value is given. So I can use these two design equations. I can place the appropriate values. I can get it. So design is not the big issue. Try to get this one. Once you understood the concept, theory part, you can design the things. But practically this circuit is not used because S value you are getting like this one. At the same time, there is no provision for a compensation. That's why you have to go for another circuit. Okay, so now I will not analyze that circuit because we will directly switch over to the third one. But for the reference, I will give the circuit like this one. Okay, so this is your VB now. This is VC. So this is IC. This is IB. And here we will play IC. that is called as collector to base bias. What if this circuit is there? It is fixed bias. This is collector to base bias. Now if I want to derive the equations for Q point, so what I have to do? Again I have to apply the KVL. So this is your input side. Now don't try, just pay the attention. यहाँ पे क्या आएगा? VCC is equal to drop across this. यहाँ पे कितना आएगा? RC into this current plus drop across this IB into this resistance plus VB. You have one equation, right? If you apply KVL to this output section, your equation is VCC is equal to this drop plus this drop. If you solve those two equations, you can have the Q point. But if you compare this circuitry with the first one, here some provision is there, some provision for compensation that is there. Just pay attention here. Suppose there is increase in temperature. What is the result? Final result? IC increases. Because of that cumulative process, IC increases. But now for this particular circuitry, if IC increases, what happens to this drop? Because major portion is IC. IB is much less as compared to the IC. If your IC is increasing with respect to temperature, this drop also increases. ये supply क्या है? Fixed है. अच्छा चलेगा. So if this supply is fixed and if this voltage is increasing, clearly the meaning is the voltage at this point is decreasing. अच्छा चलेगा. ये voltage fixed है. और ये voltage क्या है? बढ़ता है. Accordingly with temperature. So definitely this voltage is decreasing. And if this is decreasing voltage, less voltage, what about the IB? The IB is the same. How much is this current? This voltage, if I write this to be say VC, so IB is equal to VC minus VBE divided by. So very clear. If temperature increases, IC increases, this drop increases. Because of that, VC decreases. If VC decreases, obviously your IB decreases. And if IB decreases, corresponding collector current decreases. Because collector current is nothing but VR minus C. So what is the conclusion? In this circuit, a provision is there. Provision for compensation. If there is increase in IC, that increase in IC gets compensated by lowering the value of base current. Okay, that means if you compare the stability of this circuitry, the stability is on a higher side. Stability factor is much on a lower side as compared with this one. Still, this circuit is not used practically. Because ultimately, we are not interested in DC values only, or whether you need the DC values. Your focus is on DC. No. Where is your focus? Amplifier. Your focus is just to get a signal like this one. This signal is nothing but the AC signal. Are you getting this? But major part is fixing the operating conditions, DC conditions. Okay, that means finally once I fix all these components, that means my DC design is over. Operating conditions आपने fix किया, इसका मतलब क्या है? DC part is over. Then what you have to do next? You have to apply the input signal. You are getting this? Your input signal must be applied here. You have to take the output from this one. Right? So input is applied to the base. Configuration is common emitter. Output is taken from collector. And here, what is this RB is there? RB is connecting output back to the input. Are you getting this? So if some component is there which is linking between output and input, it means there is a feedback. Okay, and common emitter, we will prove this shortly. Common emitter provides 180-degree phase shift between input and output. That means if your input signal is like this one, what is the output signal you are getting? It is enhanced version, no doubt, but it is like this. So for the positive input, we are getting a negative output. For the negative input, we are getting positive. समझते हैं क्या? So part of that negative output is coming back. If you consider this to be positive, तो क्या होगा? The part of negative is coming back. इसका मतलब क्या हुआ? Whatever the net input is there, effective input is there, that effective input gets reduced. And if the input itself gets reduced, whatever the gain of the circuit output is there, that output gets reduced. So whether you require this one, a reduced input or a reduced output? No. You require more and more output. इसका अर्थ क्या है? Whatever this negative feedback is there, आप feedback plug अलग होगा. You know the feedback now. Feedback म्हणजे क्या है? A process of taking output back to the input. And depending upon the phase relations, you can define it as a positive or negative feedback. If these are out of phase, if your effective input gets reduced, that is called negative feedback. And if your effective input gets increased, that is called as a positive feedback. So positive feedback is used in oscillator design, whereas the negative feedback is used in amplifier design. Because of negative feedback, gain decreases, but still negative feedback is preferred, because that negative feedback gives various advantages like stability, okay, decrease in noise, decrease in distortion, increase in bandwidth, and so on. Number of advantages are there of negative feedback. Only limitation is decrease in gain, and that decrease in gain you can compensate by using one more stage. Gain just how I said, I can work with multi-stage configuration. Okay, that means against one limitation, I am getting 5 to 6 advantages, merits. That's why negative feedback is deliberately used in the design of amplifier. Okay, so in this case, because of that negative feedback, and again no provision is there to avoid that negative feedback. Okay, so that's why this particular circuitry finds a little bit limitations as far as amplifier design is concerned. So that's why we have to switch over to the third and the final circuit, that is called as voltage divider bias. Okay, so shall we take the break?